Hello, welcome to Chapter 8 lecture for the database class, and we're going to continue on from Chapter 7. The topic is still on writing structured query language, SQL. So it's kind of a continuation. I think in the latest edition of the textbook, they make some changes to how they kind of stack between Chapter 7 and 8. So it was a little bit of a change. That's why you're going to see some slides in here that probably relates a little bit more to Chapter 7. That's because they're just remnants of how I originally structured the course between Chapter 7 and 8 to kind of build up the skill set. But as you can imagine, right now I have to kind of scramble a little bit because of the change and try to do this online. So I added some slides that may look repetitive from the last chapter that may not kind of reflect how your Chapter 8 in the latest edition actually presents the material. But just keep in mind, Chapter 7 and 8 combined, they're actually trying to do the same thing. It kind of builds on top of each other. It's just the way the sequencing of how the author made the change looks a little bit different, but you should have everything you need in the slide. So I guess that's what I'm trying to say to you. So when you look at something and you have questions, just go ahead and relate back to Chapter 7 as you need to, even though it shows up here in Chapter 8 slides. All right, let's get started. I think we have a lot to cover, and my hope is to keep it under an hour and 15 minutes. So let's start. Let's see, where am I? All right, so data definition. Now we're gonna focus on the DDLs, data definition language, which again is still just part of SQL. In this chapter, I literally will pull up Access. And this is the video that will pretty much show you everything you will need to do for the second part of your project. So just make sure when in doubt, look at the slide that I provided you. I have them all built out into the slide. So you have the syntax, as well as look at how I use Access and how I enter those and run those. So this is kind of the lecture part demonstration for the second part of your project. So we're going to create database. We're going to see how you actually implement your design, or your particular design into Access database and build it physically. And then we'll look at all these components that goes into it. And again, the chapter kind of threw out this, I think, as a reference to the examples that it's going to provide. So I'm going to skip that. This is the data types. We talked about it in Chapter 7. Each attribute has a data type, just a quick reminder. And this is sometimes the format. For example, when you have an attribute that says age, you can say age attribute is a number type, data type. And even when you declare a data type, sometimes the data type can take some parameters. For example, right, you can say the lowest of this range of the number type will be from this point to what point, or how many decimals, right? How many precision you want. If you put a 2 there, like this one, that means the database will always allow you to enter. If you input 12.3222222, the database will actually only store 12.32, 2 decimals after the 2 digits after the decimal. So sometimes when you declare, especially numeric data types, or sometimes character data types, you can set some parameters. For example, if you say first name as the attribute, and then you say that's a variable character, meaning the characters that make up the data value in this attribute field can vary in length. That's what varchar means. But even though you say it's variable in length, you can still say the maximum length, or L, is only 25 characters, because the likelihood of somebody having a first name more than 25 characters is very, 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 very low. And this allows the database to really just kind of lock in the structure and prepare the enough spacing for what you anticipate to store. Otherwise, database do take a lot of overhead when it doesn't know that you sometimes will want 500 characters, sometimes you want 1 character. database is more structured, it's computer, right? You rather know, you know what, just tell me what is the rule and I will make sure I handle it efficiently, effectively. So no more than 25, I will always anticipate I will have the space allocated for 25. I will treat it as 25 characters. I will buffer it with 25 characters and so on and so forth. So that allows the computer system and database system to run more effectively than you say, hey, it's varchar, sometimes maybe 1,000, sometimes maybe a 1, sometimes maybe, 25,000 characters. Then you have to really allocate overhead that you 99% of the time you will never occupy those space reserved for what you want to store into that attribute. So that makes it inefficient and a waste of resources. So sometimes we identify the parameters to help, just the computer in general and the database and the software to be a little bit more efficient in storing data. So again, just quick reminder, every attribute has a data type, which is very important concept here. All right, now let's get into the hands-on a bit. So remember, we mentioned that when you actually start building out the database in Chapter 7, I mentioned this, when you have the blueprint, your ERD diagram with all your defined attributes and keys, primary keys, and foreign keys, now that's just a blueprint. Now you actually have to go create them, and you start building up your database not through data manipulation language. You started with data definition. So your database definition syntax, such as create table, is what you're going to use to start creating your first table. So the format, as you've seen from my prior lecture video, you go into a SQL area and you start writing this stuff. So you start with the syntax create table, which means you're going to create a table to the database, and then you name it whatever you want, and then you start listing now your your attributes within the table. So in a nutshell, what you're doing right now is you're looking at your ERD, and then remember you're doing the crossfoot model. So inside the ERD diagram, for each of the box and each of the table, you listed all the columns that you want: first name, last name, age, date of birth, whatever. You literally say create table, customer, assuming that's the customer, and then you just look at your ERD and start naming off, entering the attributes that you already pre-designed on the diagram. And then, but for each one, you will have to specify the data type. This may be something that wasn't shown, that wasn't really built into the ERD diagram. But technically, when you create the ERD diagram, as you create each of the attributes, at that time, you would have supposedly catalog all the attributes and their data type associated with it within another document. But for this class, for this project, I didn't ask you to do that. I figured that would just be a little bit too far ahead of all this. But here, technically, so when you start writing this, you're not trying to make that determination at this point. When you actually build it out, you're supposed to have that as part of your documentation from your blueprint, from your ERD diagram. But we're gonna take what we have, right? So right now, the attribute, you're just gonna make a decision what you want to put in here. Now, keep in mind, as you know already from part 1 of your project, because of that, I already defined it for you. So in your project guideline from the first part, which then carry over to the second part, I already told you what data type it should be. So I give you that so you don't have to figure all that out. But just make sure you do understand the importance of having to know what data type you want to use for each of the attribute. All right, so you name the column, whatever title you want to name it, you declare the data type and whatever else constraint, parameter, and so on and so forth that you want to put in there. So what does that look like? So this is the syntax that you need to write. Here is the actual sample of what are you writing. So this is the demonstration. So the SQL code that you see here actually works for Access database. So I actually wrote them all out because again, remember in Chapter 7, I said when you write SQL, different databases have a little nuances between how they translate SQL language that you're supposed to know, or you have to look it up all the time to say a certain way of writing SQL for MySQL database, But when you come to Access database and you paste the same thing in there, Access database is going to say, nope, error, I don't like it. And then you have to troubleshoot what are those nuances that you have to tweak a little bit to make it work in another database. So what you're seeing here is supposedly to be fully compatible or compilable, understandable by Access database. So I went through all that and tweaked it. So this gives you pretty much most of the slides in this chapter that has SQL code give you a good template as a reference point for you to use. And then you have to, change the context to fit for what I'm asking you in terms of creating the project. Right now, the example here is still customers, orders, and all that stuff. So I'm continuing to use the same example context for the rest of this chapter. So let me show you what this looks like in actual practice in running it. So I'm gonna cheat. I don't want to type this out. So I'm gonna come out here, and then I'm gonna cut and paste my code. All right. So I open up my Access here, and then when you open up a blank database, so in this part of the project, you're starting from scratch again. So whatever you just submit and whatever you build using Access for the first part of your project, that's gone. That file you no longer need to use. You can keep it for reference in the future, but for this second part, you create a brand new one. So you're gonna hit new, and then you go start with a blank database. All right, so back here again, here's where we are. I'm gonna close this out. So now I don't even have tables. So the goal here is not to use wizard of any sort. The goal here is you're gonna build a database purely from SQL. And then I will explain to you what I expect you to turn in at the end of all this. So let me see here, database tool. All right, so to start, we will go to create because that's what you wanted to do. You want to start creating your tables. That's the first step. The sequence of how you want to approach this, you create all your tables and attributes first, and then you can come back and create the constraints, meaning the relationships between those tables. And then once you accomplish that, then you can start inserting your data elements into those tables to populate them. And then once you insert those tables with data, then you start writing all the data manipulation language to read the information, to pull the information back out. So keep that in mind in terms of the sequence of how you want to build out your code. So again, create all the tables with attributes and the parameters and data types. That's first, and then build in your relationship constraints, meaning the tables, foreign key and primary key relationships, and then start inserting your data elements, and then start writing your data manipulation language based on what I asked you to provide, the report, and I asked you some business questions that you still have to write SQL to find the answers, and then and so on. So we'll start with the first steps, creating your tables. So to do that in Access without using all the bells and whistles to make your life much easier than having to write any code, you have to actually write the code for this part. So you go to create, you will see a query design. So in a nutshell, what that means is it's query. It's allowing you to write your own query here in this section. So let's do that. So once you click on that, you come into this mode, but right now it's not letting you write anything, you see, because again, Microsoft Access is trying to really make a software for everyday users, really try to make it dummy proof that you don't have to know anything about coding. You're supposed to click and drop down and select and hit OK, and then you will build the code behind the scene, so to make it a lot more easier for people. So what you're seeing here in the Access is try to do the same thing. It's try to say, hey, I can build what you want without you having to write SQL. You just point and click and tell me what you want to pull from the fields, from the tables, and whatever parameters that you usually would write a SQL for in the where clause. You can all do them from a user interface. But again, this is not what we want to do. So once you come into the query mode, it still try to make it easy for you. But we want to come back here and say, you know what? No, give me just the raw SQL area where I can write my own code. So once you click at that, here you are. Here is the stage for you to write SQL syntax within Microsoft Access. And this is where you're gonna pretty much live for the second part of the project, and you're gonna practice writing all that code. So I'm gonna cheat here. I'm gonna paste it. So here's what we did. We says create table. That's the syntax. And then our first table is gonna call customer. So that's the name of the table. And then I give some attribute, cust code. So that's the customer code or primary key, customer unique identifier. I just named it cust code. I can't remember why. But since this is my primary key, I use another syntax for access. It says I want this attribute field to contain the data type that's specific to access called auto increment. Remember, Access always, or any database needs a unique identifier that will never repeat, which we call primary code, right? This is where I'm telling the Access database to say, this field is the primary key where I want the number to auto increment and never repeat. And then I want it to start at 1, that's the parameter, and I want it to increment by 1. That's it. So that's what I have asked the database to do in my code. And then I said, this should never be blank, right? I put some more parameters or constraints onto it. And then I use the keyword constraint, which is what Access need to know, excuse me, need to know when it's trying to specify a particular attribute to be a primary key. So I say I'm using constraint. I want to put a constraint on this. Which makes this a primary key customer code. So in a nutshell, this particular part is a more unique syntax-wise to Access database. All it is trying to do is to make customer cust code attribute a primary key, unique, auto increment, should never be blank. Everything we know about that has to be applied to a primary key when you enter data into this table. So it's just, that's how you will tell the database to do so. Everything else tend to be easier, right? Straightforward. We have customer for last name. It's a character data type, which I'm giving 15 spaces. And then it should never be blank. Customer first name, same thing. I'm giving 15 spaces for this data type is a character or characters shouldn't be blank. And then the middle initial, if I choose to capture that, area code for the phone, and then 8-digit for the phone number because of the hyphen. So 7-digit with a hyphen, so it's 8. Now, again, even though phone numbers are numbers, we're not gonna do math because it's a phone number. So we made it a character just to store 1, 2, 3, and database treats any number 1, 2, 3, 4, 5 as if it's just A, B, C, D, E. It's just a character to the computer. It's not planning to do any mathematics or arithmetic with it. All right, now I have a customer balance, for example. That's how much money they have or credit they have with me as a business. So I did create a balance to show that another data type called integer, which is allow me to do math because it's numeric. And then here in integer, I did not specify anything other than just treat it as an integer and allow me to store numbers into it. So in a nutshell, for your part of the project, that's what you need to create. I believe your particular variation, depending on the quarter that you're seeing this, just in case I need to reuse this lecture video, some of my variation of the project require you to create 4 tables in the ERD, and some, I think this is, if this summer, usually I go with a 3-table project. So you have to write 3 of this type to create 3 tables. And if you're doing 4-table designs project, you have to do 4 of these statements. So once you have written them, you're gonna hit run, and that's just gonna execute the code. So let's see what happens. There you go. One thing about Access, if everything works, nothing happens. If anything doesn't work, you will see a pop-up. So how can you know it worked? Because nothing popped up. and plus you actually see a table being created through your code. All right, so this query created this code, this table. Now, if I close this, let me save it before I lose it. If I close this, it's gonna ask me, do you want to save it? For your particular part of the, this part of the project, yes, you have to save every single query. And then you save them by the sequence that you want me to run them in. So this is the first query we're writing, assuming I'm starting this project, right? This is the first query I wrote to create the first table, and it worked. So I'm ready to move on to create my second table for the project. But since this worked, that's what I want to grade you on for this part of the project. So I want you to save this query. Query 1, I'm going to name it create customer table. I want make sure you give a sequence, since this is the first query that you want me to run to validate that you have completed the project. I want you to give me the sequence of numeric of 1, 2, 3, 4, 5 for all the queries that you have written to complete the project. So in this case, I'm saving as 1, and then I give a title so I can easily see this query is creating a customer table. You hit OK. There it is. All right. So, so how would I grade you? When I receive your project, I'm not going to come here and look at this. All right. You all should be familiar with this view. This is what you created. And if you go to design view, this is what you created, right? You use code to say primary key. You see the little key here, auto number. You create a last name. It's a short text, which is a character. First name, initial, area code, phone number, and balance. Everything looks great. Exactly the way you want it. But I will not grade it that way. When I get your project, what I will ask you to do is delete everything other than queries. I want to access file that you submit as a team to contain nothing but 1 through whatever many queries that you have written. So if this project end up to be, I think this is probably going to be mid 20 queries that you will have to write. And then the longer ones will go, I think, right above, 30 plus. So I should see query. So you see, this is a icon of a query. I should see 1, 2, 3, 4, 5, 6, 7, 8. And what I want to do is I'm going to delete everything else. I'm going to delete the actual things that were built by your query. So the only thing I should see is just queries and then 1 through however many. And then how I'm going to grade you is I'm going to go and start running them. All right, I'm going to go in and and run them. See, yes. If it worked, now I will click on your second query and run them. And then third query and run them. And then I'll probably open it up just so I can kind of eyeball it. But you kind of get my point. So I will run your queries to recreate the whole database plus the questions I asked you, the DMLs, the DMLs. And then if everything works perfectly, I should click through 1 through and run through 1 through however many 25. Every single one of them will run successfully. I will then check the actual database, the relationship, the data that you pull back based on the DMLs I'm asking you to answer. And there you go. Now, if any time I click on something and something blows up, that query gets deducted for points. But as you can tell, right, then grading becomes a little bit more time consuming. Now I have to go fix that query before I can continue on. Otherwise, your database won't continue. So every step kind of builds on top of each other. But so make sure you test all your queries the way I plan to grade them. And that will make sure, right, you're going to get the highest possible point. If you are able to click through all of them without any errors blowing up, pretty much 99.9% of it is going to happen the same when I grade them. So that's how I will be grading them, and that's how you will be submitting your files. So at this point, we're successful. Let me just save this, just so I don't lose this. Let me see where I'm gonna say this. All right, so, all right. So there you go. There you have it. That's a good start. All right. Now I'm going to go back to the slides again. So we just ran this. So you now know, and you know the syntax of how to create tables. And this is the reference that you will use to do the same for your project. All right. Create select statements. We already gone through this, so I'm not going to go through this again. This from chapter 7. So I kind of probably copied a few slides too many. I'll change the table structure. Now, once you create a table, technically there are occasions as you continue to use the database, business do change. Business move on, and they evolve, they scale, they acquire other businesses, they launch new product lines. So periodically there's actually changes to your database that you have to account for what's happening in the business world, right, in the real world. So you have to alter your design as you continue to make your database better. So under that event, in that event, there's ways for you to alter your database, which you use the command alter. So when you alter a database, you have a couple ways to do this. You can alter a table, you can alter a data type of an attribute. So literally it allows you to make changes to your database design. But there's also, you can add columns, you can delete columns. Now keep in mind, right, if you have launched your database and then the database has been in use and it's capturing all this data based on the design that you originally implemented, and then somewhere down the road, you decide to add 3 more columns, but you already have 1 million customer data inside the customer table that you never captured the 3 new columns of information you decide to capture from this point forward. So when you do that, just keep in mind, you're creating new columns where 1 million records will not have any data to populate. So you're gonna have blanks for 1 million customers. And from this point forward, the next 1 million customer you're gonna acquire in your database will then have those information, and which kind of creates a little bit of a inconsistency in your data. So when you do alter tables, that's what we have to deal with. Now you can go back and try to recapture those information for the previous 1 million customer, and or you just find some kind of data value to represent that, hey, these are legacy customers that didn't have this information. So you put some kind of code or fake value in there to represent that, to make sure all the table attributes, because if the 3 new ones that you're about to add in are not null constraint, then you have to give something to the prior 1 million customers that don't have that data type, data attributes. So it's just something in real life you have to really contemplate on. When you alter a table, you're changing the structure design, there is business real life impact to what you're about to do. So how do you write that? This is the syntax. You alter table, that's what you do. The part and what you want to add. So this again is giving the view of how you use it. You can use add a foreign key reference. You can add the constraint. Remember, primary key and foreign key, they link, right? In the last part of your project, you just drag from one attribute table to another using access interface. You drag it, you drop it, and then it makes the relationship for you. Here in Access, you actually have to write SQL to make that happen. So you have to make sure you're referencing the foreign key against the primary key of another table, and you need to use a SQL to do that. So this allows you, alter syntax allow you to put more structural changes to your database, and this is what you'll use to make that relationship connection. So you can use it, alter table, you can drop a column, right? You can delete a column, and then you can drop a whole table if you choose to, which is bad, right? When you go into a database, you drop a table. That means you're deleting the table and whatever's in there for however long that's been accumulating. And whatever relationship is connecting to that table that's dependent upon that table is if it's a composite table, imagine you drop it, then you really, really break the schema and the relationships of your design. So it's very, very dangerous to drop a table in a live production database that's been, storing data. And unfortunately, I'll be honest with you, a few years back, one of our vendor that handles one of our very important database system did just that. They dropped a table and deleted it by accident, which took down the whole system. So it does happen accidentally. Some SQL person just wrote drop, thinking they're dropping something that's not really important. It's a temporary table that they created to do whatever report and whatnot, but they end up typing something wrong and drop the actual most important table in the database. And then it went away. And the whole database just froze because it needs that relationship to that table to operate. So once in a blue moon, it happens, and it's pretty disastrous when it does. So that's when you do drop tables in a production environment, you really, really have to know what you're doing. So what does this look like? Let's see. Let me come back out here. I do have an ad. So remember, right, this is our customer. I don't want to show you this view. Let's just get used to looking at it. This is all we got, right? We have 1, 2, 3, 4, 5, 6, 7 attributes to the customer table. Now I want to create another one. I want to alter the table customer, which is this one. And I want to add a new attribute called customer tier code. And I want to make that a long integer data type. All right, so it's very simple, just to give you some syntax to know how this works. So if I run it, nothing happens, that means it happened. All right, again, it's just some access weird thing that it doesn't give you any feedback. So if I now go back to look at this, you see a new attribute has been added to my table design. Let's look at design view. Customer tier code, again, is number. Now, long integer numbers, access, treat them all the same. This is the only data type that's available, as you already know. So when I use long integer, access understands that's a normal database term, data type. So access knows, you know what, I know what you want, but we call it number, but don't sweat it. You can continue to use the word integer. I will always just put it into the numbers. So even though the word doesn't really jive when you look at this view, but access is smart enough to know that's how SQL kind of works. So see, that's how I use alter. And then again, I'm gonna save it just so I don't lose it. Save. Oh shoot, I just save the table. I want to save the query. Yes. So again, right, this is the second one I ran. So again, I want to keep the sequence, alter, cus table. So there you go. So that's what I explained to you. Right? That's how I'm going to run this 1 and 2, because technically you cannot run 2 without 1 being run and be successful. So now just to show you how, again, just to mimic how I'm going to grade this, right? I'm going to receive the file with all this. I'm going to click this one. I'm going to say yes, no error, something came up. And then I'm going to click this one. Yes, it modified, it give you a warning you're about to change the design. Yes, and then I'll check. There you go, everything looks great. All right, so that is how alter works. And then drop table is kind of the same thing. I can say alter table customer drop, and then I give the column I want to drop, the attribute on the drop. And then I run it, then that column disappears. All right, so the syntax is straightforward. Now, I also mentioned you can create keys, relationships. So you use alter table to create relationships, and you had to do this one, right? Remember the sequence. You create all the tables, all the queries up front, 1, 2, 3, you're gonna create all 3 tables. And then you're gonna create, if you have 2 relationship or 3 relationship in the ERD diagram, each relationship requires an alter table statement to make that relationship connection. So how do you read this? You're saying, I'm gonna alter the table customer. I'm gonna add a constraint. I'm gonna just name it relationship number 1. The foreign key is customer tier code referencing customer tier tables, customer tier code. So this is how you create the relationship. Now, in my example, I'm missing something. So let's go create customer tier table. And then that way you'll make a little bit more sense. So we'll come back to this. Let me go back to out to the axis. And then I'm gonna exit out this so I can copy my code. So we're missing a table, right? We need two tables to create relationships. So create, query design, SQL, and I'm gonna cheat. Here is the table we're missing. So create table, customer tier. So the context behind this is I have all the customers that I handle and do business with. Each one of the customer, I want to give them a tier. Are you a bronze tier? Are you a silver? Are you a gold member? So that's the context. I have a table that allows me to track how, how value of a customer is by advancing them to be a gold member, diamond member, right, elite member. So there's tiers I want to give them. So I need a table to manage my tiers. And then the relationship is for every customer, each customer will have to belong to a tier. And for each tier can contain many customers in that tier. So that's a one-to-many relationship. So let's create the table first, and then we'll build that one-to-many relationship between these two tables. So I'm creating a table called customer tier. Customer tier code. So I'm going to give a unique code to represent each tier. And the same thing, auto increment, never repeat, constraint, primary key, blah, blah, blah. Now, the only attribute I have in there is the tier title, nothing else. So I make it very simple. What's the tier? So run it. There you go. It's successful, right? Save it. So 3, alter. Oh, sorry. This is create a tier table. All right, so I created the second table. I'm gonna close it. Now I'm gonna show you, right? Based on your first part of your project, that's why I asked you to do the first part, is now you can come here and you can look at, you have both tables created, right? Now remember from your first part of your project, to create a relationship without writing code, you will draw from the 1 and you will drop to, sorry, brain is frozen on me. All right, you drop the customer. Each customer tier can have many customers, customer tier code that we altered and added. So once I do that, I have to reference it first. Hold on. All right, let's skip this part. Let's come back to this. I'll show you the visual. What I try to do is I'll try to show you, you can use code to literally recreate everything that you have seen in the first part of your project. But let me continue with my code and then we'll come back and do that. I think I'm missing a step right here. So that's what we have so far. So the step is, let's use the code to create it, and then I will show you how the line, the relationship between the two tables actually gets created, and we'll flip it back to that view again. So let's go back here, SQL, and again, you will use the alter command to actually build the relationship. And here's the syntax, right? Here's what you see in the slide. Alter table customer, add constraint, form key. So what you're doing here is you're going into the customer table and you're telling the database that you're about to create a relationship. But you create a relationship by looking at the table and specify the relationship in the table that receives, that contains the form key. So remember when we create using the user interface in the prior part of the project, you actually start dragging from the primary key table, you drag the primary key and then you drop it onto the form key of the second table. In the SQL of how Access wants you to do it is you have to reverse that. You have to actually write and alter the table of where you would have dropped the primary key onto. So it's kind of try to work it backwards. So you're telling the database, the customer table, customer tier code inside this table is the foreign key that has to reference the primary key of another table called customer tier. And the primary key attribute is called customer tier code. So by doing so, see, you're identifying the foreign key referencing to the table of the primary key attribute. And then it's gonna kind of dub this as a relationship one as a name behind the scene. So that's how you would do it. Let's run this. There you go, nothing happened. That means everything happened. So now, let me save this, right? Always save something that works. For create relationship with customer and tier. There you go. So now if I run this in sequence, everything will build out as I designed it. I'm gonna close this. Now let's go take a look at what happened. You see, the line got created through code, not through you dragging this and dropping onto it. All right. So, so this is kind of the way I'm going to come in and take a peek. So it's easier for me to check whether or not you did the code worked the way you designed it. So let me see here. Let's close this. So everything checked out. So far, so good. Everything's working as I've written them. Let's go back to the slides. All right. So alter table. That's how that works. Now that assuming, right, I'm not going to actually build out more tables. I'm just going to use this two as a demonstration. So now that assuming you got all the relationship done, table created, relationships all done, now you have design, your design is now implemented with no data. So now we're going to kind of simulate you building data. Inserting data to your newly designed launched database that's blank. So you use insert statement to insert information into your tables. So insert into table name and all the columns of data that you want to actually populate. And then you can, it uses select. No, you know what, let's look at this one. Insert into table name and then all the values of the data, actual data that you want to insert in. This is the most basic way to insert data. So you already know the values that you capture through your form, through your application, through your website. Wherever you're getting those values, people's first name, last name that people fill out, you're actually building this statement on the fly and then send it to the database to actually insert them into the database. So there's multi-tier of programming at work to help you structure the insert into statement. But since this is only purely database class, I'm not gonna go through how to build the front end, the website. You already kind of get a glimpse about how you do that with Access Database in the first part of your project. But in reality, database sits behind everything. So database actually don't have what Access have, giving you an interface to build out forms and whatnot. Database job is not to do all that stuff. It is programmer's job to write another front end application that handles all this accumulating, capturing, asking for data. And that programming will dynamically create this insert statement and then send it back to the database. So all the database is waiting for is, hey, whatever you do, just send me a valid, good insert statement with all the right value that you want me to handle. I will just do that job. But however you get those values, the database actually don't care. So in this part, we're just gonna pretend we're writing the whole thing, that we structured the right insert to pump in the data. All right, so, and then this part is just to say, sometimes when you try to pump in data, your data actually is not coming from a user, you're coming from another database. So you can massively insert tons of data into your table if those data values are coming from another table. So you can insert into a table with all the attributes by selecting, right? This is a subquery, selecting the actual data you want to pump in from another table. So that's what this second part is trying to show you. You can subquery or nest query to find your data that you want to pump into this table. All right, so let's take a look at this. So I give you some code. This is what we have, customer code. This is actually the sample, the demo that we have been working on so far. So select statement, I'm not gonna go through it. You already know what that is. Where's my insert? All right, sorry, let's continue with insert before I jump to the next one. So let me show you what the syntax actually looks like in Access, because I have it right here. Copy it. So create, query design, SQL again. So I have two of them, but SQL only, Access only allow you to run one statement at a time. So insert into customer table, which I have here. I want to insert customer code, customer last name, first name, initial, area code, phone, and balance. All right. And then once I identify all the ones I want to enter, then I give the value. I say value is 1 that coincides to the first attribute listed up here. And then I say I want to enter Smith, which coincides to the second attribute in the second space after the first comma. So you have to make sure you sync up the position with the attribute listing positions on the top. So that's very important. And then if it's numeric, you can just enter the number without the quotes. If it's character, if it's syntax or just words, you had to put it in quote. Now remember, the data type for area code was character, varchar. So it's character, which that means even though it's 626, it's actually need to be treated like a character. So it's not math, it's not data numeric data type. So 626 has to be put in the quote to insert them as just a character. So that's it. That's how you write insert. And if you want to populate your database, you write a lot of inserts. But in real life, the program actually writes the insert. We will write a program that writes insert statements for us. So we don't actually create them one at a time. So let's run it. You're about to append, which means insert one row into your database table. Yes, done. Again, habit, make sure something works, save it. Insert customer number 1, because I'm going to write multiple insert, right? So that's the first insert. So it's right here. You see that when you write a data definition language, the icon Access give it to you is you can see the blueprint construction icon. So that tells you those SQLs actually alters the structure of your database. And you see this one, it has a plus. That means this SQL is actually adding data into your database. So sometimes eyeballing the icons, I can tell what that SQL is doing. All right, so let me just do 2 data points. So we have both of them in there. Create, let's do this one. So I have the second one down here, so I'm gonna create this. Now keep in mind, right, since I'm manually doing this, I had to force an auto increment. So I have to keep track of how many customers I have in there. So now I'm going with value 2, because remember, customer code is primary key that should never repeat. So I have to keep in mind, since I'm manually creating data and not let the database create the key values, I had to make sure I'm auto incrementing this value here when I do more inserts. Same thing, the rest, run it. You're gonna append the second one, another row, yes, append it. It worked, save. This is query number 6 in the sequence. I'm inserting customer number 2. All right, so I can close this and close this. Let's go look at what we have in here. Voila, we have 2 customers. Everything is populated, no blanks other than customer tier. Remember, our query failed to recognize, I do not have customer tier right here. Therefore, it's left blank. So I kind of did it on purpose, but I'll just go back and populate them manually later. But you kind of get, that's how we do insert. So that's the important piece. We'll come back and play around with the customer code later, or tier later. All right, let me go back to the slides. All right. So now, right, we've seen how to do select earlier. So if I were to, just to give you a demonstration, right, in chapter 7, I show you how to write select in another database, which is not access. So here I just want to say, this kind of works the same thing. Select all from customer. There you go. If you run it, you will get everything. So you can pretty much do everything that we have done in chapter 7 when I kind of walk you through how to use select, where, clause, and all that. All of that you can do here too, with the exception that you just have to make sure you figure out the nuances, which I think I provide most of you in the slides, the code samples that will work for access. So select, just a quick demonstration, right? Customer code, that's all I want to know. And customer last name, oops, from customer. So I only want to see 2 attributes. Oops, see, that's a perfect segue. When you see that happening, usually it means you mistyped something. Therefore, the database didn't know what that was. Usually I use customer as a C-U-S-T, but in this case, I use as C-U-S without the T. So this is undefined in the database. They don't know what that is. So it's asking me to answer that. So when you see this pop up, check every single spelling in your statement. Something probably were misspelled, most likely. So this is the case. And then I think I'll probably do the same here, I'm guessing. There you go. So that fixed it. So you see I only asked for two columns coming back. All right. And then I need to go to SQL view. So that's, that's just wanted to share with you whatever you, everything that you saw from the last chapter on the select, from, where, having, group by, everything can be done here as well, which you will need to do in the later part, in the last few SQLs you need to write for this part of the project. All right, let's continue. And then you can update. All right, you can write update queries. So the syntax is very simple. Now that you have a record in there, you can update the data in there. For example, customer balance, right? When customer, draw down their balance or money, whatever, you have to update that value from $9.99 down to $5 left in the account. So you have to update and change. So you're not inserting new, you're trying to change and modify existing data values that's already stored. So you use the update statement to do so. So what does that look like? Here's the example. Update customer table, and I want to set. So update and set are the keywords here inside SQL. So update customer table, I want to set customer area code equals 713, where customer code equals 1. So it's pretty user-friendly when you read this. It's saying for customer code that is 1, which is John Smith, I want to update the area code to 714. So you're saying whatever it is right now, I wanted to change it to 714. And that will then alter this number to 714. So, so let me copy this. Let me go back here. So let's do this. So that's the same code that you just saw on the slide. So let's run it. You're about to update one row. So just double checking you're about to change the data value. Yes, I just did that. And then it worked. So let's save it. SQL 7, update customer. So you see update icon looks a little bit different. It's not adding, it's whatever that is. Now let's close it. Let's go look at customer. Voila, we changed the 626 to 714. So again, update is one of those statements that programmers at the front end handling, the website or whatever the application is responsible for constructing by their programming to send to the database. So when you go to UCR, I don't know, iLearn, I don't know if it allows you to do it. If you want to change your phone number or something, you fill out the form online, you hit submit. behind that website page that took what you just submitted is actually manipulating, creating an update statement, and then send it back to your student record database. And then the database says, oh, all right, I trust who the program is coming from. I will take your statement, I will double check it works, and then I'll run it, and then boom, your phone number just got changed inside the record of UCR. So it's the same exact concept. You're just kind of mimicking it using Microsoft Access database. But the SQL statement is created at the programming side. All right, so let's continue. Got a lot to cover here. You can delete. So I'm not gonna show you this one. You kind of get the point now. Delete. This is the actual statement that will work inside Access. So I don't want to delete anything that way, so I have to put it back. Delete from customer where customer code equals 1. Guess what's gonna happen? When customer code equals 1 as the condition, the where condition, is gonna wipe this record out. Keep in mind in Access, when you actually do delete something, you can never use the 1 again, because the database, remember, it will never let you repeat using the primary key that it already has in memory. So if you start testing stuff, you start removing your records because you're using it as a test. It's always to just go ahead and wipe out all your tables and run your queries and get it back up to where you want it, just to keep the 1, 2, 3 area primary key still kind of in a sequence. Otherwise, when you do a lot of inserts, you have to remember where you left off. Even though you wipe out all your original first 5 inserts, you have to start with 6, 7, and 8, unless you wipe out the table and recreate it from scratch again. So just something to keep in mind. All right. Selecting, so we already gone through this in chapter 7. I'm not going to repeat it. I kind of showed you how you worked here in Access as well. So here's a couple more. Definitely, I recommend you to try all of this. So create your own database. Even though this is kind of a group project, I highly recommend you try all of this individually, because you have to know how to do this, and there will be questions on the final exam that ask you to recognize, which statement would do what type of work. So it's not about, which group member wrote the working one and submit the project, everybody got good grades. It's about on the final, you have to recognize all the SQL statements yourself. So highly recommend everybody has to do this to be successful. Everybody should know how to do every single SQL statement shown in the slides. Try it, practice it. And more importantly, do it for the project as well. So you have to contribute, because like I said, if you don't build the whole project yourself, maybe some of the SQL you won't be able to recognize on the final exam. So I think I mentioned before, this is actually structured as a group project, but it can easily be individual submissions. But my point of making a group project is for team, for collaboration experience. So every single one of you should do all of this, and then just combine which is the best one and submit that one. All right, enough said, continue. Comparison operators, we talk about alias. So I didn't get a chance to show you what that is. Here's one. So you see, right, customer last name, customer F name, customer initial. That sounded bad. Anyway, customer area code. Sometimes those doesn't really mean much. But let me see, where's my alias? Let me just show you an alias code really quick. So how you actually do one is inside a SQL or using SQL. Sorry, clicked the wrong thing. I'm not gonna do forms here. Query SQL. So again, select, I want customer code, customer last name, customer first name. But then, first name, F name sounded bad. So it's not really good to show that on a report to my boss. So I'm gonna say, instead of listing as a first name, I want to use an alias as people. So that's all. I'm just adding the alias. I believe I can do the same here as last name of customer. So that makes it very easy to identify what that actually is. Even though I still have to say that's what I want from the database, but I want the result to come back and have a title of this. That's what alias does. See, I changed the column name in the report that came back. Last name of customer and then people and so on and so forth. So that's how alias works. Just want to get that out there. All right. Alias, update, update code, update customer, set customer balance equals customer balance plus 1, where customer code equals 1, right? When we try to update a customer balance, you're not gonna try to say, hey, somebody just made a deposit of $100,000 to the bank account. Oh, update all my customers with $100,000. No, you want to be very precise who you're updating that $100,000 deposit to. So that's where, remember I mentioned the where clause is very, very important. It sets the criteria and the condition of what you're actually, which record you're gonna do it to. Otherwise, you're gonna end up updating everybody's balance, which is bad for a banking system, right? So this syntax gives you a provision, a precision of what you're updating to. So let's just look at it so we can see the syntax working. So update customer, set customer balance. So I want to set and change. I'm updating it. Where balance equals customer balance, which is existing balance, whatever's in there, plus I'm giving them $1 million. Where customer code equals 1. If I don't have where customer code equals 1, then everybody gets the $1 million. So that's what I'm trying to make here, the point I'm trying to make here. So run it. Customer balance, sorry, old habit. Doesn't have a T in my sample here. Run it. Customer code. Another one here. There it is. All right. Are you about to update 1? Yes. Save it. Where am I? I'm on 8. Update customer balance. Let's go look at it. There it is. It was 10. I give them another million on top of it. So now it's $1 million and $10 in the customer balance. All right. So customer number 1 is very happy. I just give them $1 million in the database. All right. So that's how that works. So you have the syntax here. You can also put more select, right? Select from customer where customer balance is less than 500. So which customer is going to be pulled back, or customer code equals 2. So either one of them has to be true for the SQL to return something back to me. So let's look at it. Who has a customer balance lower than 500? Actually, I think nobody now because, yep, nobody, because I just give customer 1 $1 million and you can see nobody's below 500. But or means, all right, nothing came back from this one. The second criteria is or customer code equals 2. Do I have that? Yes, I do. Customer code equals 2, which has 1,000. And this is going to come back. So I'm not going to run it to you. You have the code right here that you can try. So I'm just going to try to read off what the code will be doing. Order by, customer order by. So I kind of showed you from the last sample, last chapter lecture inside MySQL. Same thing is going to work here. I give you, this is what the syntax is. I'm not going to show you the code. This is maybe try it out. Try to use customer balance ascending. You know, select everything from customer, order by their balance or order by their customer code. Do ascending and descending, right? Practice that and see how that works. And then the same thing, having and all that stuff. All right. So this is all the syntax you have seen from last chapter. Here is the code that you can try. Select customer tier code, customer tier, blah, 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 blah. Let me see here. this is group by. So remember, when you see a period between the two in the select, this is now ahead of the period is the customer, it's the table name. Once you say the table name is this dot, then what follows the table name after the period is actually one of the attributes within that table. So that's, again, the shorthand of calling out, being very precise. I want customer tier code from customer tier table, not the customer tier code that is in customers table. Because inside the customer table, I also have a customer tier code attribute because that's the foreign key. Okay? So to make this work, I guess I do want to show you this just so you see how this works. Let me go back. So I'm gonna kind of cheat a little bit. Nope. I'm gonna go in here and create some records in a quick way. Customer tier 1. It's so customer tier number 1. I'm gonna call it diamond status, right? 2. Oh, come on. 2 will be gold member, and then silver. So pretend that, let's say that's my 3 tier. So you can either be a diamond member, a diamond customer, gold customer, or silver customer. So I'm gonna close this. Now I'm gonna go to customer, remember, right? I have a tier code. So this is a foreign key. So let's give the customer diamond. I'm just gonna create another one. Sorry, I'm gonna cheat here. Whatever, and then I am the silver member. So each customer actually belongs to a tier now, and then that will be diamond, and silver. So now I have some data that we can play around with. So let's go back here and let's do some select. Let's try some of this. All right. Copy. I'm going to cheat. I got all this. So select customer tier, customer code, customer tier title, and then customer, and then count how many people. So what I'm trying to do is number of customer. This is an alias. I'm doing an alias, so we know what we're doing. So somebody asked, how many customers do we have in each of the tier? So that's the question. You know, the boss came and said, you know what, we have 1 million customers and they all have a tier. Where we stand today? How many customers are in each tier? So I can figure out what freebies I want to give some diamond customers. If there's too many of them, I may want to give them a cheaper stuff because, you know, it's gonna cost me too much to do so. If there's not a lot of diamond members, there's only a handful of them, then I want to give them, you know, a $500 gift certificate to kind of say, thank you for being such a highest value customer, blah, blah, blah. So right now somebody wants to say, give me a report just to show me how many members are in each of the tiers so I can kind of decide how much budget I want to allocate to give them a bunch of freebies. So based on that business context question I get asked, I wrote this code. So I'll let you kind of read through this very carefully so you can kind of see what I'm trying to do. I'm trying to match up and do a count between the two tables. And then I want to group them by so I can see the count result based on each tier. So if I run it, there it is. So I answered the question. Hey boss, right now tier number 1, diamond, we only have 2 members. We also have a silver tier, we have 1 customer that's in that tier. That's it. So, you know, our data is only have 3 customers, so that's why you see the low number. But imagine the same code would have worked if you have 2 million customers that all belong to some kind of 3 tier. Then this number will really be meaningful to say, all right, if I have 20,000 diamond customers, and if I try to figure, you know, give them $100 each freebies, that's $2 million budget of freebies. Then I might say, you know what, that's too many. You know, my budget is 1 million. So let's think of something that's only $100, right? Or $50. So you kind of get my point. That is how you write this. So let's save this. Since it worked, where am I? 9. This is a, I don't know. This is a select number in tier. I'm making it up. I don't know. All right, so that's a select. All right, so that's what I wanted to show you. Let me jump back to my slides. All right, so that's what this does. So now you have the code to know how to write select from where group by. That's a sample for you. Now let's talk about joins. Now in terms of joins, this is one of the more advanced way of thinking about SQL. However, looking at the time, what I want to do is I will stop this lecture here up to this point, and I'll create a second part of the video for this chapter 8. Reason being is I know long videos is pretty tiring to go through for most of you. And keep in mind, right? Chapter 8 includes. I'm also doing the demonstration, so I'm not really doing a separate demonstration video for your project. I kind of merge it into this. That's why this is going to end up to be a 2+ hour chapter, but more than half of it is probably just the demonstration teaching you the technical skills of using Microsoft Access. So we'll continue with this chapter talking about joins in the second part of the video. All right.